Okay, so linear simultaneous equations elimination. So we did substitution yesterday, or today in our last lesson. Now, elimination is just the other way to solve a simultaneous equation. So sometimes it's much harder to solve these simultaneous equations by using substitution method. Okay, so we can use a new method called the elimination method to solve these. So basically, it just means that we use the substitution method whenever we have. We use it whenever we have an equation that's like y is equal to 2x plus 3 and then x plus y is equal to 7, okay? Where we can substitute it in and then work out the value, okay? But we're not always going to be given equations that are in the form of that. Sometimes you might be given equations that look like x plus y is equal to 5 and x minus y is equal to 3. And then the problem becomes, well, what two numbers solve these equations? Now, we can't substitute one in because we can't just replace one of the letters in one of the equations with everything in the other one, because we just don't have like y is equal to or x is equal to. So we don't have these, okay? So how do we actually solve these ones? So the way we do it is we either add or subtract. So what we're going to do to begin with is we're going to start off by actually just adding or subtracting some equations to eliminate x or y. So the idea is we want to remove one of the variables by subtraction or addition. So if I have two equations like this, x minus 2y is equal to 1 and minus x plus 5y is equal to 2. What you're going to do first is you're going to say to yourself, okay, do I have any pronumeral, so the x or the y, where the value, so I don't care about the plus or the minus just yet, but if the value is the same. So looking at this first one, you can see that both of the x's are there's just one of them. There's a positive 1x and there's a negative 1x, okay? But that's what I'm looking for. I'm looking to see if I have the same amount. Now, I need to add or subtract depending on what I have. If I have opposites, I'm going to add. If I have the same, I'm going to subtract because I'm going to eliminate it, okay? So if I've got a positive x and a negative x, if I add those two together, it will give me an answer of 0. Whereas if I was to subtract them, so if I did x minus x, well, that's the same as x plus x, which is the same as 2x, okay? So I want to add these ones in this case. So what I'm going to do is I'm going to put a plus sign there. Okay, so when I do this plus sign, I'm going to treat this like a giant sum. So I'm going to start off by doing x plus negative x. Okay, so x plus negative x, well, that's just equal to 0. Okay, so that's the first step done. Then I'm going to do minus 2y plus 5y. Okay, so minus 2y plus 5y, which we know is just equal to 3y because it's the same as 5y minus 2y. So I'm going to put plus 3y is equal to, okay, and for this last bit, it is 1 plus 2, so 1 plus 2. Okay, so 1 plus 2, and that's just equal to 3. Okay, so that's how we add those ones up. Okay, so let's look at another one like that. So in this one, we've got 3x minus 2y is equal to 5 and 5x minus 2y is equal to 11. So we're looking for something that has the same value. So again, we don't care about the plus or minus, but the same value. Now, hopefully you see that we've got a minus 2y and a minus 2y here. So 2y for both of those, and they're both negative in this case. So because they're both negative, what I'm going to do is I'm going to add these two together. I'm going to subtract these two. Not add. We add when they're different. We subtract when they're the same. So instead of putting a plus, I'm going to put a minus up here. Okay. Now I'm going to solve it like I did the other one. Treat it like a big sum. 3x minus 5x. Or in other words, 3x minus 5x. Now it's important you do this the right way around. So top minus bottom. Okay, so 3x minus 5x, well, that's equal to negative 2x. So I'm going to write that down there. Okay. Then I'm going to do minus 2y minus 2y. So if I remove this, minus 2y minus 2y. So if I write that out, minus 2y minus 2y. Now we know if there's a negative, two negatives directly next to each other like this, they turn into a plus. So minus 2y plus 2y, or in other words, 2y minus 2y, and that's just equal to 0. Okay, so plus 0 on there. Okay, and then the last bit is, so I'll erase all this. So the last bit that I need to do is I need to do 5 minus 11. So 5 minus 11, which is equal to -6, like that. Okay. So that's how we eliminate a variable. Okay. So as you can see in both of those, we started with x's and y's, and in the last line, I've only got a y left over. I've only got an x left over. Okay. So it doesn't matter which one we try to eliminate, but we can eliminate either one to get us off. Okay. So that's what question 1 is asking you to do. Question 2 is to decide if addition or subtraction is needed. So question 1, we've got 2x minus 3y is equal to 3, and 3x plus 3y is equal to 7. So do I need to add or do I need to subtract? Well, if we have a look, I've got 3 y's here and a plus and a minus. So because the 3's are the same, then I need to plus and minus. So if they're different, then I am going to add them. So for these ones, I need to add. Now for part B, we've got 3x minus 4y is equal to 8, and minus 3x plus 7y is equal to 10. So again, we're looking at the things in front of the x's this time. So we've got 2 3's are the same. We've got a positive 3. Remember, if there's nothing there, it means positive. And we've got a negative 3. So positive and a negative, they're different. So I am also, for these ones, going to add them together. So if they were the same, of course, we would subtract them. But no, because those ones are different, we add them. Whoops, so I'm going to write add here as well. Okay, so let's actually solve our first simultaneous equation. Okay, so we're going to do this by first adding the equations together. So it actually tells us how to do this. So we're going to start off by saying, okay, well, if it didn't tell us how to do it, how would we actually do this? So we've got 2 y's, so they're the same here, and we've also got 2 x's that are the same here. Okay, so because we've got both the same, the y's are the same, so we could use minus, but because the x's are the same too, and they're different, we're going to actually add these ones together. Okay, just because that's what it tells us to do. So the way we started off is by putting our plus up there and drawing a line underneath it to treat it like a giant sum. So remember back in like primary school, you'd do like 302 plus 407, like that, and you'd add it like this. We're doing the same sort of thing, but in the reverse order, basically. So we're going to do y plus y. Well, y plus y is just 2y. Okay, x plus negative x, so x minus x, well, that's just equal to 0. Okay, do we have to write the 0 down there? Well, we don't actually, because we know if we're adding 0, that's just like adding nothing, so it's just the same as having 2y. Then lastly, we've got 12 plus 6. Well, 12 plus 6 is just equal to 18. Now, from this point onwards, we need to work out what y is equal to. So to do that, I'm going to divide both sides by 2. So divide by 2, divide by 2. And that leaves me with y is equal to 9. Okay, so that's my first answer. So the first number that is true for both of these equations is when y is equal to 9. Now what we're going to do is we're going to substitute into either one of these two equations. It doesn't matter which one, so pick the one that looks the easiest. I'm going to pick the bottom one in this one. So y minus x is equal to 6. So they both look relatively the same. I'm just going to use this one. Actually, you know what? I'm going to use the other one. I'm going to use y plus x is equal to 12. Okay? So what we're going to do is we're going to substitute the 9 in. So wherever we see a y, we substitute the 9 in. So 9 plus x is equal to 12. Okay? So in other words, what plus 9 is equal to 12? Well, if I subtract 9 from both sides, we get that x is equal to 3. And so there's the solution. So if I put those both in, it should make it true. So 9 plus 3 is certainly equal to 12. And 9 minus 3 is, of course, 6 too. Okay, question 4. Now, these ones are a little bit, well, okay, well, this one, all we asked to do, so this time, instead of adding them together, we're going to subtract them together. And the reason we know that is because, well, the x's are different in this one. So I've got x and 2x, but the y's are the same, and they're the same sign, so they're both positive. So I'm going to subtract them. So I'm going to put the minus up there, put my line underneath, because I'm going to treat it like a big difference. So y minus y, so y minus y, we know is just 0. So do I need to put anything down for that if it's 0? You know the answer is no, but you can write 0 if you want to. But we don't need that 0 there because we know it's just nothing. Now we've got x minus 2x, okay? So we know that's the same as x plus 2x because the two minuses make a plus. So we know that's the same as 3x. So our first bit of the puzzle is 3x, okay? So I can rub that out now. Okay, our last bit is 3 minus 0. Well, that's nice and easy. 3 minus 0 is just 3. And make sure your equal signs are under equal signs. So I've got 3 lots of x is equal to 3. Now to get the x by itself, we're just going to divide both sides by the 3. And that leaves us with x is equal to 1. And that's our very first solution. So x is equal to 1 in that case. Okay, now to find out what our other value is, so our y value, we're going to substitute that x into either one of these two equations. Now, it doesn't matter which one again, but I'm going to look for the one that looks the easiest, and I think the top one looks easier. So 1 plus x, y plus x is equal to 3. So if x is equal to 1, that goes y plus 1. So remember putting it into that equation there. So y plus 1 is equal to 3. Subtract 1 from both sides, and that gives us y is equal to 2 as our solution. So there we go. There's our solution to that one. Right there. Okay, question 5. Solve these equations simultaneously by first subtracting the equations. Okay, so the only difference here in this one is that we've got 2 minuses with our x's. But again, we're going to follow the same method, and because it's telling us how to do it, we're going to put our own little minus up there. Okay. So start off with y minus 4y. So if I go y minus 4y, well, we know that is negative 3y. So I can put that on here. Okay, minus x minus minus x. So we know that the two negatives become a positive. So this is the same as minus x plus x, which we know is just 0. So again, I don't need to put anything because it's 0. And I've effectively eliminated the x from my equation. 12 minus 2, well, that's just 12. Okay, so I remove this stuff. Bloop, bloop, bloop. So 12 minus 2 is, 14 minus 2 is just 12. Now to get the y by itself, we're going to divide both sides by negative 3. Okay, just because, remember, if the number is next to the letter, you have to do divide. The minus is just saying there's a negative that we're multiplying it by. So divide by negative 3, divide by negative 3. We get y is equal to 12 divided by negative 3. Well, that's just negative 4. Okay, and there's our first value. Now we can work out our second one by substituting that into either the first one or the second one. It doesn't matter which one I choose. I'm going to choose the first one because it looks a bit easier again. Okay, the reason why I'm picking the first one over the second one, well, I've got 4y minus x versus just 1y minus x. Okay, just a little bit easier for my half. Okay, so y minus x is equal to 14. So let's substitute the y is equal to minus 4 into that equation. We get minus 4 minus x is equal to 14. Now we've got minus 4 minus x, so the opposite of minus 4 is plusing 4, so plus 4 and plus 4. Okay, so that leaves me with minus x is equal to 18. So if minus x is equal to 18, then that must mean that x is equal to negative 18. And there's my final answer. So therefore, y is equal to minus 4 and x is equal to minus 18. Okay, so you don't actually have to put that final sentence there, but I'm just doing it just to fill in a bit of time to make that 10 minutes. All right, so that's how we solve the ones that look like in question 5. So again, it's basically just the same thing, but with a minus instead of a plus. Now, the ones that we're going to be doing in question 6 will look like this. So it says solve the equations, and we're going to do that simultaneously again. Okay. And it doesn't tell us which one we're going to use. Okay, so we need to work out is it a plus or a minus. So the checklist is, 1, we're going to check if we have the same value. Okay. Step 2 is to check the sign. Okay, and then step 3 is to eliminate and solve. Okay, so you know those steps are like kind of like the you know, to how to draw an owl, draw the circle and then draw the rest of the owl. But you know, it's a good little check to sort of say to yourself, okay, this is what I need to do. So step 1, same value. You need to make sure that we have the same value. Otherwise, if we add or subtract, then we're going to lose something. Like, we're not going to lose something. Okay. So if we have a look at this equation here, the first thing you should notice is that we don't actually have any values that are the same. We've got 3x plus 2y is equal to 6, and we've got 4x minus y is equal to 8. So the question becomes, well, how do we eliminate something like this? Well, what you can do, and you are allowed to do this, is you can actually make one of the equations have the same value as the other one, or give it so that it will have the same value as the other one. So what I mean by that is, well, if I multiply this whole equation by 2, okay, so that is 4x becomes 8x, minus y becomes minus 2y, and equals stays as equals, but 8 becomes 16. Okay, if I then compare that with the other equation that's already there, okay, you'll notice that now I do have the same values. So all I had to do then was just multiply my equation by 2, and you are allowed to do that as long as you multiply everything by 2. Okay? So, with that being said, we can now use the elimination method to eliminate one of our variables. So start off by drawing a line underneath and deciding, well, what's the sign that I need to use? So I've got a negative and a positive 2y, so they're different signs, so I'm going to add these ones together. Okay, so then doing this, I go 8x plus 3x is equal to 11x. Negative 2y plus 2y, well, that's just equal to 0. But then equals 16 plus 6. Well, if I add those together, I should get 22. Okay, so 11x is equal to 22. To get the x by itself now, we're going to divide both sides by 11. So divide by 11, divide by 11. So my final answer is x is equal to 2. Well, not my final answer, but my first part is my x is equal to 2. Now with this, I can substitute into either of the 3 equations that I've made. It doesn't matter which one you substitute this value back into, you will always get the same answer. Now remember that equation 1 is by itself, but equation 2 and the third equation that I made, or I created from equation 2, they're exactly the same equation, except one's just been doubled in size, okay? But they are exactly the same. So you can pick whichever one of the 3s that you want to do it into. Now for this one, we need to decide, well, which one is the easiest. I'm thinking that this one here, the second equation that we have, is possibly the easier one. So I'm going to substitute my x into that. So 4x minus y is equal to 8. Okay, so substituting my x into here, so where it's equal to 2, I get 4 lots of 2 minus y is equal to 8. Okay, or in other words, 8 minus y is equal to 8. Now, how do I get rid of this 8 that's on the left? Well, remember, it is a positive 8, okay, because it is just by itself. So remember, this negative goes with the y, but this 8 is a positive 8, so the opposite of that is to subtract 8 from both sides. That leaves me with y minus y is equal to 0. So if minus y is equal to 0, then that must mean that y is also equal to 0. Okay, so you can write a little sentence to finish off. It's not necessary unless it asks, what are the solutions. So therefore, x is equal to 2 and y is equal to 0 are the solutions to these simultaneous equations. Okay, just like that. So one more example for these simultaneous equations. So solve the simultaneous equations solve the equation simultaneously by the elimination method. So again, it's always this elimination method that we're doing for this one. Now, the question becomes, well, if I go back to my checklist, 1, so values, are the values the same? 2 is the sign, so are the signs the same or different? And then 3 is to eliminate and solve. So for this one, the question becomes, well, what are the values? Like, what values can I use? Now, you'll notice that again, that the values are different. But you'll also notice that I can't just multiply, I can't multiply one of the equations by a number to turn it into the other one. So I can't multiply 4 and 3 to get to 3 or 2. And there's no no whole number, and keep these at whole numbers, by the way. There's no whole number that I can multiply the bottom 3 to get to 4, or this bottom 2 to get to 3. Okay, there's just no numbers that work for that. So what we can do instead is we can actually multiply both of the equations. So there's nothing stopping us from doing this, because remember, when we're multiplying the equations, it's the same equation, it's just been scaled up by a factor. So we can do this for both of them. Now, the easiest way is to look at the 2 smallest values that you've got. So in the pairs. So I've got 4 and 3 for x's, and I've got 3 and 2 for y. So the smallest values, or the smallest numbers, are the 3 and the 2. So I'm going to focus on those ones. So what I'm going to do is I'm going to multiply the equations by the opposite value. That was weird. By the opposite that's weird. Anyway, by the opposite values. So if I've got the 3 in this one and the 2 in this one, that means I'm going to multiply this whole equation by 3, which is the opposite of that 3 there. And it means I'm going to multiply this whole equation by 2. Okay, so just the number. Don't worry about the negative or the positive, just the number. Okay. So when I do that, I rewrite my two equations. So the top one becomes 8x plus 6y is equal to 36. And my second equation becomes 9x minus 6y is equal to 15. So as you can see, now my y's have actually shared the value. By doing the opposite multiplication, it actually makes it so the equations will give you the same value for either x or y, depending on which one you chose. But in this case, we got the y's because we used the y's, the numbers from the y's. Now we've got a plus y and we've got a minus y, so the opposites means that we are adding these ones together. Okay, 8x plus 9x, well that's equal to 17x. 6y plus minus 6y, plus and the minus next to each other. So 6y plus minus 6y. When the plus and the minus next to each other just become minus. So 6y minus 6y is 0, and that's equal to 36 plus 15, which is equal to 51. Now, to get our x by itself, we're going to divide it by both the left-hand side and the right-hand side by 17. And that should give us x is equal to 3. As 17 times 3 is equal to 51. Now again, I can substitute this value for x into either equation number 1, equation number 2, equation number 3, or equation number 4. Now I'm not going to do it in 3 or 4 because there's just no point, because those equations are much bigger than the other two. Now it's just a matter of picking which one between 1 and 2 am I going to substitute it into. In this case, I'm going to pick equation 1 because it's all positives and I like positives. So 4x plus 3y is equal to 18. And I'm going to substitute the x is equal to 3 into this equation here. So that becomes 4 lots of 3 plus 3y is equal to 18. So remember, when there's two numbers next to each other with brackets in between, it's times. So 4 times 3 is equal to 12. Plus 3y is equal to 18. To remove the 12, I'm going to subtract 12 from both sides. And that leaves me with 3y is equal to 6. Dividing both sides by 3, and we get y is equal to 2. So with that being said, that gives us our solution. So therefore, our solutions to this simultaneous, or these simultaneous equations are when x is equal to 3 and y is equal to 2. Okay. So that's it. So we're only doing questions 1 to 7 from your textbook today. Okay, and they are on the slide if you do need that access. But other than that, there are quite a few there. But again, this is the hardest stuff that we're going to be doing in this topic, and potentially for the rest of the year. There are some other trickier little stuff coming up, but it is one of the hardest things. So make sure that you do get it. Please ask questions if you need extra help. I'm more than happy to answer them as we go, but just make sure that you do, okay? So with that being said, I'll see you guys in the next video.